A clean column of pure water of length h is contained in a, this should be clean, vertical capillary tube, right? As shown in the figure, using a small syringe needle, more water is injected so that the height of the water column increases. This water column height is increases. Okay. The variation of the reciprocal of the radius 1/r of the lower meniscus of water column with the height is to be considered. Which of the following graph correctly represent the variation of 1/r with h? Okay. In order to find the correct relation, we need to know, right, an equation for the pressure difference and the radius of the meniscus, right? This meniscus we can call as upper meniscus. Okay, right, meniscus MENISCUS, right. This is lower meniscus. Right. Here atmospheric pressure will be there. Let's say that as pi. Here also the atmospheric pressure will be there, right? So the atmospheric pressure we can take that as P naught, that is pi. And we can mark a point here, that means the point just below the upper meniscus, and Y is the point just above the lower meniscus. Okay, now we can write the relation. We are injecting water in the upper part so that this height is increasing, and as we know, water is the contact angle of water is 0. Here the contact angle we can consider as 0. When the height is increased, what will happen? This radius of this meniscus will vary in the sense it will become like this. At one instant it will become flattened, and thereafter the shape will go something like this. Okay, that means in the lowest meniscus the angle of contact we can't neglect, right? So here we can neglect that as can be considered as 0. So the pressure difference, we can write the formula for the upper meniscus. Okay, P naught minus Px equal to 2T over radius of the tube. Let us assume that as R. R is radius of the capillary tube of the, okay. Now we can find Px. Px is P naught minus 2T over R. Let's say this as equation 1. Similarly, for the lower meniscus, right, the pressure difference P naught, this is the highest one, and this is the lowest one. So P naught minus PA y is equal to 2T over radius of the meniscus as R. So we can say, we can find Py from this. What is that? P naught minus 2T over R. This is equation 2. So from equation 1 and 2, we can say, by equating this or What is pressure at y? Or pressure at y is equal to pressure at x plus h rho h. So pressure at y minus pressure at x equal to h rho h. So this will be from equation 1 and 2, Py minus Ps equal to 2T over capital R minus 2T over small r, that is h rho h. Now we can find 1 over r. 1 over r is equal to what? The relation is 1 over r should be in y-axis. So 1 over r will be minus rho g by 2t times h plus, right, plus if you rearrange we can get this one, 1 over r, it will be like this. So the format is clearly y is equal to minus, this is considered rho g 2t surface tension t m x plus c. So the possible option A can be the first one and fifth one. Fifth one, we can choose fifth one because, right, we can choose the fifth one because when water is injected further, this meniscus will become flattened and thereafter this will become like this. So the pattern of the graph will be in the other way around. That means earlier it is y is equal to minus mx plus c, then thereafter after this meniscus becomes like this, right, then graph will take the other form, y is equal to mx plus c. So this is the possible option. Okay.